Hi everyone, my name is Clay, Staff Software Engineer from OpenC3, an open source, open architecture, command and control system for everything. I'll be giving a demo today on our product Cosmos on how it can help you, what it does, and how you can use it to bring all the different pieces of your system together in one place. Let's get started. Welcome to Cosmos. The first thing you will see when you enter Cosmos is going to be the command telem server. From here, you can get a high-level overview of what I have connected on my Cosmos instance, the various targets that I might have, the command packets that I am sending out to my various targets, the telemetry that I'm receiving from all these different targets, routers so that I can receive commands from an external source to send it out to our targets, and visualize our data flows that may be happening. But from here, I'm able to get a quick glance as to what's currently going on my system. I can get a quick glance as to all the different commands that are coming in and telemetry that's flowing out. I can see what I'm connected to and disconnect and reconnect dynamically from here. Down below, I have log messages, the most recent log messages that are flowing in, just so I can get an overview of all the different things that are happening in our system. On the top right, we have notifications. So this is going to be persistent across all the different tabs. But from here, I can take a look at all the different notifications happening. If we're hitting any limits, all that's going to be notified here. In our demo today, it is a particularly noisy demo. Things are coming in and out of limits dynamically, and that is on purpose, just so we can showcase all that Cosmos can do. In the top right, we can take a look at our user. I'm logged in as an admin user at the moment, so I'll have all the different accesses for today's demo. As well as some news, we do have a monthly release that we aim for, so there's always many changes happening to our Cosmos Core and Cosmos Enterprise offerings, so you'll be able to take a look at all the different things that are happening in our system there. Limits Monitor is a quick tool that you can use to visualize all the different things that are in and out of limits at this moment in time. When I have this open, I can take a look at what of my mnemonics are coming in and out of limits. And down below, I can see all the different events that are happening around it, so that I can quickly visualize and get timestamps on what particular items are coming in and out of limits. I also have some extra controls here. So if I was taking a look at a particular item, let's say this temp3 item, I can right-click this and then get details directly from here, in which I can get further details including the raw value, converted value, formatted values, any conversions that may be used, units and maybe their definitions of them, as well as a visualization of the entire limits so that you can understand where this item is within its limit spectrum. I also have the option to click Graph, which will take us straight to Telemetry Grapher, which we'll revisit in a next section. I also have some further controls where I'm able to ignore the entire packet, ignore the single item, or temporarily hide item. This is really good if you have a sensor that's particularly noisy, or maybe we want to ignore temporarily. You can do that directly from there. There's also more functionality, including saving configurations, opening configurations, and changing limit sets. In our temp3 example, we have the default limit set as well as a TVAC limit set. Perhaps we have different sets of limits we want to use depending on what operational mode we're in. And in that case, you can dynamically switch that and configure that from our configurations, and then be able to switch from the UI which limit sets we want to be using. From Command Center, we can send out manual commands directly to our targets. So from here, I can select the inst target, and I can select the packet, let's say the collect packet. And then quickly, all the parameters that are necessary for this command are visualized. None of this is manually done. Depending on the configurations that you have, these will dynamically populate to fit whatever the command defines. From here, I'm able to choose the normal type of collect, and then I can change the duration. There are ranges specified so that there are range checking default enabled as part of Command Center. And then from here, I can directly send out these collect commands. I have this very helpful screen on the bottom right. This is also configured to be able to pop up so that you can show a little screen so that you can monitor different telemetry as you send out these manual commands. If I have a special command, this is a hazardous command. So anything that is hazardous, you'll be prompted with a warning just to make sure that you do indeed want to do this. And I'll approve and send out that command. For anything that exceeds our ranges, so if I have a duration of 11 and the acceptable range is 0 to 10, that is going to trigger the hazardous warning, of course, and then have an error letting us know that there's a runtime error with the duration is not in the valid range. Down below here, we have a editable command history. And what is super helpful here is that directly from here, I could copy this and then use it in our scripts so that I have the exact command that I sent directly built in through Command Center. Or I can just hit enter and that will send out commands directly from there. Or I can even edit this. Let's say I want to change the temperature to 10 and then hit enter and that will send that out as well. So it really makes it user-friendly and able to send out these manual commands quickly and easily. I'm also able to change a variety of modes, including ignoring range checks, displaying state values in hex, showing ignore parameters, so on and so forth. As an example for ignore parameters, for a lot of these CCSDS type protocols, you might have CCSDS headers that aren't really necessary to be shown every single time. And something like packet ID, we don't necessarily want to change that. So that's a helpful thing that you can hide from the ignore parameters, but also display if you need it. From the command queue tool, you're able to create a command queue so that you can stage a variety of commands directly in a queue so that they can be released using the queue system at time of contact or at a scheduled time in the future. So given the command queue, I'm going to create a new queue here called demo. And then I'm going to start adding some commands to this. So I'm going to add to our inst target, let's say an abort. I'm going to add a collect with normal. Lastly, I'm going to add an array command. So with everything in our queue, currently it is in the hold mode, which is going to be the default mode, where everything is added to the queue and not released. When it is released, all those items from the queue are going to get sent out chronologically. Right now, I can take a look at this. I can see the 3 different commands that we have in the queue. All of them are going to be validated on the run of these commands. But I can also edit these dynamically. So if I wanted to edit some of these, maybe I want to change one of the values. Maybe I want to change the temperature to 20 here. I can update that command so that my queue is ready. And maybe I wanted to run one of these out of order. So let's say I wanted to run the array command a little bit earlier, out of sync with everything else. I can hit play and that's going to directly run that out. Then when the queue is ready to go, maybe at a time of contact or sometime in the future, we can change it into the release mode. And that's just going to send out all the different commands and we're able to verify that in the command history in the next tool. From the command history tool, you can view all the different commands that have been sent out using a time filter. So from here, I'm able to verify all the different commands we sent from the command queue, as well as the previous command sender, as well as the microservices that are running in the background that are sending out commands in our demo environment. So I can take a look at all the different commands that are running here. I can also take a look at any validation results. So if any of the commands have validators, that can be in Ruby and Python code, all of that can be validated and we can see how those are processing. That previous queue that we have that array command sent out, and then the 2 that were in the queue that were also sent out right afterwards. From here, I'm able to change the start date and end date so that I can view specific time ranges, and I can also export this so that we can visualize it at a future time. I can also apply some searches, so from here I can take a look at specifically, perhaps I want to look at all the different abort commands that have been sent, maybe all the different collect commands that have been sent. All that can be quickly searched and filtered, and then of course paginated as well. The next tool we're looking at is going to be notebooks, and this is a very exciting new tool that has been introduced as part of Cosmos 7 for enterprise customers. And from here, it's going to look similar to like a Jupyter Notebooks or an eProcedures idea, where I'm able to create a notebook. I'm going to point it to the inst target, and we're going to call this demo. And then from here, I can add a variety of steps. So first, let's say I want to add a markdown. And this is just going to follow typical markdown format. Done. And then next, I'm going to add, let's say, a screen. And maybe that is going to be the file display widget. And then next, let's say I want to add a script, and we can, I'm going to add, hello. Great. So what this allows us to do is we're able to build out this notebooks that is able to have markdowns, arbitrary scripts, arbitrary screens, so that we can also run these as tasks. So you'll be able to audit exactly who did what and go through these items, and then build these notebooks out customized so that you can write out any notes. Perhaps you want to show custom screens so that you can build out your entire procedure list in one place. So from here, I'm going to hit start. And I'm going to, let's say, okay, I verified my markdown. I'm going to hit check. I verified my screen. I'm going to hit check. And at the very end, I'm going to run start on my screen, on my script here. And that's going to run this Ruby script. And I get some more meta information about that. My procedure has been completed. I'm going to hit complete. And boom. And then from the execution status, I can view all the different completed notebooks, and I can take a look at exactly what was done and how it was completed, and if any notes were there. So this really gives us a really flexible tool into building out these procedures for any sort of complicated INT environments. The script runner tool is probably the most versatile tool that we have here in Cosmos because it allows us to write arbitrary Ruby and Python code to manipulate and control and automate all the different targets that you are controlling through Cosmos. So from here, I'm going to open a sample file that we have for our demo here today. So in our procedures, I'm going to click the one that says collect, and I'll open this up. We have a lot of guidance and APIs that are available on our documentation at docs.openc3.com that can walk you through a lot of different features and sort of the different APIs you can use to control and automate and orchestrate your hardware or software. But from here, what I'm going to do is I'm going to run this script. And it's just going to show us how we can use a variety of ways to prompt the user, have sort of human-in-the-loop interactions. I'm going to enter a number here. It's going to ask me for another number. It's going to ask me for a prompt. I'm going to click OK to start the normal collect. It's going to import some code from somewhere else as a library. I can also send out hazardous commands, and it'll do all the regular checks that come with that. Continuing here. Continuing all these different commands. But really just showing that we can run these arbitrary scripts in Ruby or Python, which allows us to do so much more than just hardware and software orchestration. It can also hit external APIs. You can also use it to create new files. Anything that you can write in Ruby or Python, you can do it here as well. So there's so much that you can do. It's a very, very flexible tool to develop anything you might need to automate and orchestrate. Any of my scripts that has been executed, I can take a look from the execution status and take a look at my running scripts. I can visualize all the logs. Everything in Cosmos is logged, and that's going to be one of our core tenets so that we can view all these different logs, everything that happened in our system. We can search it, we can find it, and we can download it. Script Runner has line-by-line execution, which is an awesome feature as part of Cosmos. And what that means is that if I have a sample script like this here today, but let's say there is a small typo in this. And this is intended to fail, and it's going to fail. But if I run the script, boom, it will catch the error. And then after the error is caught, you can then decide what you want to do from here. Maybe this error was related to your hardware. Maybe some of the telemetry values were off. Maybe one of the commands you sent didn't pass validation. Whatever it might be, you have a lot of options from here. We can continue the script. so that we don't have to stop there. We can just keep running the rest of the script. We can try retrying. We could also stop the script, or we can also left click and then run a go to so that you can actually jump to a different part of your script so that you can maybe perhaps run a different part of your script, or even left click a selection and then execute a specific selection of code. So there's so much that script runner allows you to do and gives the user total autonomy over how they want to orchestrate and control their hardware. From Packet Viewer, we're able to visualize all the different telemetry packets that we have for our individual targets. So I have here selected the inst target, and I have the ADCS packet, which is the attitude, determination, and control packet. And then from here, I can visualize all the different items in my packet. Up top here, we have some derived telemetry. Some of the items that Cosmos has added is for like when this packet was created and when this was received. As well as down here, we have the individual packet items. Very similar to many of the different apps where we can visualize an individual value. I can right click this, hit details, and I'll get all the different information about my individual telemetry item. Whether it's the raw value, converted values, formatted values, if there's any units we want to see, and if there's any limits identified, we can view all that here. I'm going to switch over to the health and status packet. And then down here, I can view all the different telemetry items, and we can visualize things like array data. Maybe it's binary data down here. We have some numerical data, and we have some string information. All that can be visualized all in one place. We have a variety of derived telemetry in here. So temperature 1 high, temperature 1 low. If I right click for the details here, these are derived telemetry. These are not telemetry items that are actually coming from my target, and they are something that we are creating via code. So in this example, we have the processor conversion that's running to generate this for us. This is the high water, so it's just looking for tracking like the highest temp 1 value that's been recorded and monitoring that. All these derived telemetry is going to have the star icon, and I can also select and choose what we want to show here. Maybe I want to show some of the ignored items, which is in this case going to be the CCSDS headers, like that. And then I can also choose to maybe move the derived items last because maybe those aren't as relevant to me. So they're going to be towards the bottom here. And then additional configurations to show what we want to look at. We can change it to formatted values, converted values, raw items. And then more options here. We can always change the refresh interval. And we have a concept of stale data where if the packet has not been received in more than 30 seconds, which is going to be the default, the values are going to turn into like a purplish color just to visually show that that data is now stale. And yeah, we should get some new data before we make any assumptions about what's happening in our system. Telemetry Viewer is going to be our dashboarding and visualization tool. From here, I have a variety of screens that are predefined. So let's say I want to show the ADCS screen. I have a commanding screen. I have a graph screen. All the variety of screens that we have pre-built for this, you can take a look in our demo. From the ADCS screen, I can visualize some numerical information. We have some different visualizations here. These are some examples of how we can position different pieces of data. Down below here, we have interactable screens where we have buttons that we can click to actually send out commands. We can run scripts directly from the screens. And then on the right side here, we're able to look at the graphs that we might be generating. The best part about Telemetry Viewer is that everything here is very simple to customize and build. Everything here is going to be text-based configuration, so is most of Cosmos. So you don't have to become an expert in some custom syntax or some XML field to build out some custom whatever. It's going to be a very simple text-based screen that is going to be very user-friendly and be able to adjust on the fly. If you are a LLM user and are a fan of using a variety of LLM tools, I found that that's also been a great way to build out these screens quickly so that you can use a variety of AI tools to make your process of building out custom screens and custom visualizations significantly faster. In our demo, we have a lot of examples of custom screens that you can build. We have like a health and status screen where we can take a look at a variety of limits that might be happening. We have a roll-up so that you can take a look at a roll-up of statuses in your system. So maybe my ground transmitter, I want to take a look at what is making it green. I can click into individual roll-ups to see what's going on in our system. The sky's the limit when it comes to building out your custom screens. We provide a lot of examples that are noisy and showing all sorts of examples and ways you can build out your screens in our demo. But we really encourage our users to take advantage of this and build out whatever they might want for their custom screens so they can visualize and orchestrate their all their systems as effectively as possible. From Telemetry Grapher, I can graph out individual or multiple variety of telemetry items that we have in our system. So from here, I'm already currently visualizing the temp1 from inst. So I'm going to add to that. So I'm going to choose my health and status packet. I'm going to add temperature 2. I'm going to add temperature 3. And then let's also add a second graph. And I'm going to minimize these so that I can actually see them side by side. And then in my second graph, I'm going to show temperature 4. So we're able to visualize all the different telemetry information that's coming in and graph them dynamically. You can also right-click to edit more custom fields in here. I'm also going to display the limits so that we can visualize exactly like where we are in our limits when these different telemetry values are coming in. These fields and these configurations are something that you can save and open dynamically so that if you have a layout that you like, you can save it and then open it at a later time. And this can also be shared across all the different people that are using Cosmos in your system. I'm also going to change the start time of this. So I want to look at the past hour's worth of data. So an hour ago was 8 p.m. So I'm going to click that, and then this is going to dynamically fill and show us the past hours of data. Cosmos 7 is now powered by a time series database. So data retrieval of this historical information is significantly faster, and it's going to give us a lot of power to visualize historical information as well as real time, what's coming in right now. All right, from Data Extractor, we're able to extract data. So whether it's commands or telemetry, all the different historical commands and telemetry, we can export it directly from here so that you can use it in post-processing or whatever other things you may have. So from here, let's say I want to take a look at the inst target. I want to look at all the abort commands that I sent. And you can also choose the specific items that you want to show. In this case, I just want to add the entire thing. So I'm going to show this here. And then I can also dynamically change some of these. So maybe I don't care about the CCSDS headers. So I'm just going to clear those out. And then once I am satisfied with what I want to extract and in the time range that I want to, it defaults to the past hour. I'm going to hit process, and that's just going to download directly a CSV formatted, or it's going to be by default CSV formatted, or you can also choose to be tab formatted so that I can use that in Excel or some other tool to dynamically view and look at my data. All right, from Data Viewer, I can take a look at specific types of data and actually view the raw data that's coming through. So let's say I want to look at the ADCS packet from the inst target. I'm going to add this data. You can visualize it as raw or DCOM. So in this case, let's first look at it as a raw data format. And then we can really watch this come in really quick. So I can live look at all the different raw data that's coming in for our ADCS packet. It's going to be hard to read, of course, because this is raw data and it's not super user-friendly. So I can adjust this. I'm going to open a new one, looking at the same ADCS packet for DCOM. And then in this one, we will be visualizing in a more decommutative format. So it's going to give us that key value format and be able to visualize like all the data that's coming in very quickly. This allows us to scrub back in time as well. So if I want to look at a specific point in time, I can go back and visualize all the different raw or decommutated data so that I can see what happened exactly point in time. From Calendar, we're able to create a timeline and activities that can be scheduled for the future so that we can have automated commanding and scripts that will run for a scheduled time in the future. So starting here, I'm going to create a new timeline. We're going to call this demo. And then on the demo timeline, I'm going to add a new activity. Let's say this is going to be called script run at midnight. I'm going to have it start at 11:30 and then goes until 12:30 a.m. on the next day. I'm going to have it run a script. You can choose all the different scripts that you already have created on your Cosmos targets. So let's say I have one called collect. And then I can see this item that's appeared on our schedule that runs, I guess, 11:30 at night and then ends sometime in the morning. And it's been created. I'm going to also create another one here. I'm going to have it start very soon so we can visualize what happens right now. I'm going to have it also run a script. I'm going to have it run the streaming script. And that was scheduled to be run very soon, so it's going to start here in a few seconds. And then we're able to visualize all the different activities that are happening. You can also create notes, and you can create metadata fields so that you can fill out your calendar with arbitrary items. Now that this thing is running, we see the little loading icon, just showing that the script is running in the background. On the top right here, we also see that the script is running, so we have scripts at 1, just showing that we have something running in the background. After a few moments, we'll notice that the script has now gone to 0, and then on our calendar item, the loading icon has now disappeared. And when I click into it, I can actually take a look at exactly what happened. It was created, it started with script ID of 4, it was running, and it had completed 22 seconds later. From calendar, we can then also create multiple different timelines. So we have a new, let's say, demo 2 timeline. After having created the demo 2 timeline, I'm going to create a new timeline activity for the demo 2 target. And let's say this is a contact that's going to occur in the future. It's going to be a reserve type, which isn't actually, it's just going to block that time and just kind of show it in the UI that there is something happening that's taking up that time. And I'm able to show something that's blocking that time. So we can build a variety of different timelines, a variety of different notes and activities that run in individual ones. And then we can also build out something that might be recurring. So perhaps it's like a recurring check round counts. As an example, let's say this runs at 10:30 p.m., ends at 11 p.m. And this is a recurring activity that happens, let's say, every 6 hours, and I'm going to have it end in 3 days. I'm just going to reserve it just to kind of visualize it, and then boom, we're able to show this thing that occurs every 6 hours periodically, and then we can visualize all that. So you can dynamically build out these calendar schedules so that you can have all your future contacts, all your future planning, maybe something that occurs overnight so that engineers don't have to be in the place. All this can be automated and orchestrated through Calendar. Autonomic is an excellent tool to use to build out if-then type logic so that you can have autonomous flows on your different telemetry items. So as an example, I'm going to build out a trigger, and I'm going to call this too hot because we're going to react to the temperature sensor. So I'm going to choose my inst target here. I have the health and status. I'm going to choose the temperature 1 to trigger off of. We have a variety of operators that we can choose. I'm going to go with the greater than operator. And on the right operand, we're going to go with a value. There's a variety we can choose from here. You can choose to compare against another telemetry item. You can compare against a limit state, another trigger, a value, or a string, or a regex. In this case, I'm going to choose a value of, let's say, 40. So I have created my trigger here, and it looks like it's already enabled because it is over 40 degrees on my temperature 1 sensor. I'm going to create a reaction to this, something that corresponds to this trigger, and I'm going to call this cooldown. And then I have 2 types of reaction that we can have set up here. We have an edge trigger, which runs once when that trigger is activated, or a level trigger that is continuously triggered as long as that trigger state remains true. I'm going to choose our too hot trigger here. And then as a reaction to this, I'm going to run a command, the inst abort command here, with a notification of error saying cool down activated. And this is so that we can show that on our notification bell. And then I can add a reaction snooze, so maybe we don't want to trigger this all the time, and we want to add a little bit of a snooze in between events. So the default is going to be a 5-minute or 300-second snooze. So that reaction is now created. It's going to deploy that as a microservice. And looks like that trigger is currently running and the reaction has just been enabled. So on our top right, we also should see right here the notification saying cooldown activated right here. We can also see all the events as part of our Autonomic events down below here, so we can visualize and understand what happened at what time. Looks like now that trigger is now set to false, so we're no longer going to see that reaction occur. Since that occurred recently, we also have the snooze, so we can view exactly when that is going to be snoozed until. All these can be individually enabled and disabled, and we also have the ability to export and import these triggers as a JSON file. From Bucket Explorer, we're able to take a look at all the different items that we have in our actual storage and visualize it in one place. So as an example, I can take a look at all the different config files that we have. So everything that we use to deploy our Cosmos plugins and whatever I built for them, I can actually view, download, and visualize all right here, so that you don't have to go into S3 for AWS deployments or maybe like your Docker instance to figure out all your files. This is where we can also take a look at our log files. So all the raw logs, text logs, tool logs, all that can be found directly in here. So maybe I want to look at my raw telemetry history. I can actually get the exact bin files directly from Bucket Explorer. The System Health tool allows us to be able to have a quick glance at how Cosmos is performing on your system. So at a high level, we're able to look at some CPU, memory, and disk utilization metrics, as well as all the variety of process matrices that we have down below, Redis metrics, and disk usage of your system, so that you can monitor the health of your Cosmos deployment. We also have the ability to configure different notifications. So if CPU, memory, or disk hits a certain threshold for a certain amount of time, we're able to trigger reactions so that we get notifications about what is happening in our Cosmos system to make sure everything is running healthily. From our Log Explorer tool, in the Command Telemetry server, we do get a small log portion, but sometimes I want to look at historical logs. Sometimes I want to look at all the logs that all in one place. So using Log Explorer, I can look at historical and current logs, all visualized right here. This is a large list of logs that we got going on here, but we can take a look at everything that's happening in our system. We can also narrow it down from logs to like notifications. So things that pop up on the top right are going to be notifications, and I can filter down for just one or the other. I can then filter down for specific things I want to look at. So maybe I just care about health and status information. I can apply my filter to narrow down my searches so that I can get exactly what I want and take a look at the logs that I care about. Cosmos has documentation built in, which means that if you are in an offline environment or if you're in an air-gapped environment, you're able to have the documentation directly in Cosmos. So you don't have to have an internet connection. This comes pre-built into Cosmos. So from the documentation tab, you can go directly and view all the logs that we have. So if you're in a pinch and you want to look at some scripting APIs, you can look at that directly within Cosmos without having to leave for an internet access facility. The OpenC3 App Store is the one-stop shop for all plugins that you may need to integrate with Cosmos. Whether it may be hardware control, software functionality, protocols, integration with different vendors, there is a ton of plugins that are available, both open source and enterprise, depending on the plugin. Check that out at store.openc3.com. And from here, you can directly click, view, and download whatever plugins that you may want to help grow out your platform and build out all your needs for Cosmos. Users can download plugins directly from Cosmos without having to actually navigate to store.openc3.com. They can go to the admin console, click the Browse Plugins tab, which will open up the OpenC3 Plugin Store UI. And then from here, you can install anything that's open source and public, you can download directly. Enterprise customers can also get access to more plugins from here. And from here, I can look at all the different things that are involved. So maybe I have this Skippy-based power supply that I can install directly for enterprise users. Maybe I have some KSAT integrations that I want. I can install that from here. And then maybe in this case, I want this open source space weather alerts. You can verify the different plugin variables, look at the plugin.txt, and upon an OK, I can install that, and that'll just go through the regular process of installing this plugin onto Cosmos. The App Store is going to be the one-stop shop for all these different plugins so that you can get your entire test rack or your software setup or your system setup up and running as fast as possible with a bunch of just one-click installs. Thank you very much for watching this demo. If you have any further questions about the enterprise offering and what it can do for your team to help speed up and integrate all your systems, please let us know. And otherwise, we're so excited to see what you will be building with Cosmos. Until next time.